A very good afternoon to you, students. Now, after the equilibrium of after reduction and equilibrium of coplanar forces, next I'm going to discuss with you is center of gravity. So, by center of gravity, we define it as the point is that point in the body through which, if suppose you have this rigid body or a system of particles rigidly connected to one another, then the CG of this is the point through which the resultant weights of this whole body passes in whatever manner the body is placed. If you place it either in this position vertically or horizontally, but the CG is the point through which the resultant weight of this whole body acts or passes. So we define it as the center of gravity of a body or a system of particles rigidly connected to one another is that point in the body if it exists, because the center of gravity, it may or it may not exist, but if it exists, it is the point through which the resultant weight of the body, the resultant weight of this body always passes in whatever manner the body is placed. And note that the CG of a body or the center of gravity of a body is unique. So here, suppose how to prove it. Suppose you have two center of gravity, say G and G prime. So according to the definition here, the center of gravity is the point through which the resultant weight passes. So as G and G prime, they are both the center of gravities of this rigid body. So it is the point, so therefore G prime are the points through which the resultant weight of this body acts. And we know that the weight of a body always acts vertically downwards. So therefore, in whatever manner the body is placed. So let us hold this body in such a way that this G prime is horizontal. We hold it in such a way that this G prime is horizontal, and the weight which is a vertical, so you hold it in this way. So G prime is horizontal, or we can say that G prime here, if this is a rigid body, and then G prime, this is G and this is G prime, where both the center of gravity, where G and G prime are the center of gravity. Suppose the rigid body has two CG, okay? So we hold it in such a way that this G prime is horizontal. And we know that the weight of a body always acts vertically downwards. So it cannot pass in this direction, or it cannot be in this direction, but it is acting vertically downwards through this, and it cannot pass through both this center, but the resultant weight cannot pass through both G and G prime unless this G and G prime, so here if you hold it in this way such that G prime is acting vertically, so the weight of this body cannot, which is a vertical weight, cannot pass through both this G and G prime unless this G prime go inside. Therefore, we cannot have two center of gravity, or we can say that the center of gravity of a body is unique, means only one. You cannot have two center of gravity for the same rigid body or the same system of particles rigidly connected to one another. So now how to determine the CG of a thin uniform rod. How to find the CG of a thin uniform rod? Suppose here you have, this is a thin uniform rod, okay? You draw it nicely using scale. Let AB here be a thin uniform rod and G be the midpoint of AB. Now what we are going to do is to find out what is the CG of this thin uniform rod. So G here is the midpoint of AB, means AG here is equal to GB. Now from these two rods, consider two equal infinitesimal length, PP prime and Q prime, such that two equal infinitesimal length mean the length of PP prime is same as the length of Q prime, means PP prime is same as Q prime, which is equidistant from G, means GP here is same as GQ. So since here the rod is a uniform rod, the weight of PP prime, the weight of this element PP prime and the weight of this element Q prime will be the same, and both acting vertically downwards. So if you have the blue, and the blue be the weight of this small element PP prime and Q prime, so it acts vertically downwards. And the resultant of this, as we know from unit 1, if two parallel forces P and Q are two parallel forces, then the resultant of this will also be parallel, that is P plus Q. So therefore the resultant of the weights of this W and W prime will act at G, the middle point of this rod A, B. Because they are two equal and like parallel forces. W and W prime, they are equal and like parallel forces because they are parallel in the same direction, and their resultant will act at G. Since AG here is equal to GP, since AG is equal to GB, the whole rod can be divided into two pairs of such equal infinitesimal length, such which are equidistant from G, and then you can find out the resultant of those infinitesimal length also. The resultant of those two also will be acting at G. Hence the weight of this whole rod, if you continue to divide for each pair, the resultant will passes, or the resultant weight will act at G. So hence the weight of the whole rod will be at the point G. So the middle point G here will be there. The middle point G here will be the CG of a thin uniform rod. Okay, because you continue first, this is AB, this is G, you divide two equal infinitesimal length, means P prime, Q prime are two equal length. So since they are of equal length and the rod is uniform, so they will have the same weight, say W1, W1. Again, which is equidistant from here? The distance from here is same as the distance from here. Similarly, you continue to divide two equal infinitesimal length, say the weight W2 and the weight W2, and the resultant of each of this, resultant of this and this will act at G, since G is the middle point, and similarly the resultant of this, because they are like parallel forces, so therefore the resultant also, which is a vertical weight, which is a vertical force, will act through G. So you continue to divide this rod into two pairs of such equal infinitesimal length, and you will see that the resultant of all those will act at G, the middle point. Hence the center of gravity of a thin uniform rod is at the center, or at the midpoint of the rod A, B. So this complete the explanation.